Elektra. My name is Anthony Berdeux. I come from France and I arrived a bit more than 2 years ago in Thailand for a postdoctoral position co-funded byฬาลงกรณUniversity and the NARIT. And I am working in high contrast and high resolution imaging, which basically means that I am looking in objects in outer space which are very dim, very close to a very bright object. So high contrast and high resolution. A few months ago, actually, analyzing archival data from the SPHERE instrument, which is an instrument in Chile on a very big telescope, I discovered that around Elektra, which is a big asteroid of the main belt in the solar system, there was a third moon, so already 2 moons were known, and I discovered that there is actually a third one, which makes the system the first ever detected quadruple system in the solar system. And my work as a data scientist is actually to work on improving the performances of the data analysis tool with these new tools, which are working better than the previous one. Looking back at the same data, actually there was no 2 moons but 3. Actually, when people think about astronomy, people think big telescopes and very complicated instruments on one side, and on the other side, people behind their desk analyzing the data and having some model of the universe. But actually, there is a third part, which is a bit less known, which is like in between the telescope and the astronomer, you actually need to process the data. And so my work actually is to make the link in between these two worlds. So you need to actually put in this algorithm the physics of the instrument to model the instrument very closely to what it is in real life. And once we have a very nice model of this instrument, you can better understand its data and remove all the artifacts that you may have still inside. In 2019, when I was working on this new algorithm for this instrument, I was looking in archival data to get some nice data to show in my article that, okay, this algorithm is working better. And I was actually looking at very famous objects, which are the moons of Jupiter, because they make very nice images through this instrument. So I was processing this data. And it happened that the same night that the moon were observed by the instrument, Elektra was also part of the observation program. So I was like, oh, I have my tool already calibrated for this night, so why not also processing the Elektra data? This costs nothing more. And so I ran the program, and that's where I found something orbiting around Elektra, which was, oh, okay, this is maybe a new moon. But then Elektra is a very bright asteroid, and the moons are very faint. So when they are too close from the asteroids, you cannot see them. You need the light is blinding you. And so what happened is when you discover a moon, the first things you check is, okay, if this moon also here at another epoch, at another date. And so at the date I discovered it, the moon could be clearly seen. But when I looked at data which were taken 2 weeks later, it was far less obvious. So back in 2019, I didn't dig into further on this because actually I was preparing my stay in Thailand coming at NARIT. So last year, in September, one of my colleagues also working with me on the new data algorithm techniques, looking for data for a proposal to observe objects of the solar system with this instrument. And to advertise the proposal, my colleague asked me to send back the data of Elektra that I processed back in 2019. And at that moment, I said, oh, I remind you here that I had a kind of a feeling that there was something, but I was not sure. So at this time, we decided, okay, it's time to actually look a bit better in this. And so I went back to the other data sets, so taken 2 weeks later. And then here at NARIT, I developed a new algorithm to actually get rid of this light, which is very bright, of the main body, to suppress it in order to better check what is in the vicinity of the asteroid. And with this new algorithm, it became very clear that at all the data sets, this third object was here. And so we have, okay, this is a discovery. Now, if you have like a third moon at 3 different epochs, which is orbiting around Elektra, there is no doubt anymore. And so yes, the final discovery, being sure of it, came last year. Yeah, so this is exactly the exciting part of this. It's like here, as you just said, it was just random that I was looking at Elektra. And it happened that, okay, these data were stored for 5 years. In physics, you would say, okay, what is the probability that picking one asteroid out of many randomly, and around this one there is a third moon, and this is the only one? Of course, the answer is maybe not. Actually, what we are thinking is we need to go back to the archival data and redo most of the processing with these new tools, and we are expecting to discover more, of course. We need to understand that this discovery is actually, okay, great for itself. The discovery is very nice. This is the first multiple system, but it also shows that with new algorithms, you can push the limits of the instrument even further. And so this discovery is exciting because it shows that, okay, we have a third moon, but also a lot of new things can be expected from previous data. This is a project which is called EVWACO, standing for the Evanescent Wave Coronagraph. A coronagraph is actually an instrument which is in charge of blocking the light of a bright object. So let's say that you want to study exoplanets, which are planets that are orbiting around stars which are very far away, and the star is actually very bright compared to the planet. So if you just look at the data like this, there is no way that you can see the planet. It will be hidden by this starlight. So that's why you use a coronagraph. So the aim of this object is to block the starlight, but not block the light of the exoplanet. So NARIT is developing a completely new kind of coronagraph here, which is the only one in the world like this. So this is still an ongoing project. We are working in the lab to characterize this technology, to know if it is better than others, what it has better and what it has worse. We have to understand what are the limits. And when you are working on a coronagraph, this is actually only half of the project. And this is what actually you see at night when you look at the stars. They are flickering. And so this is also happening in your instruments. So you have your coronagraph, and you want the star to be behind the mask of this coronagraph. But if you let the atmosphere here, the star is actually moving around. And so the starlight is actually not blocked by the mask anymore, and then you don't see the companion, you don't see the exoplanet. So half of a coronagraph is actually what is called the adaptive optics system. So an adaptive optics system is basically something looking at the turbulence real time, and inside your instrument you have what is called a deformable mirror. So this is a mirror which is not flat but can actually change its shape, also real time, to compensate for the atmosphere turbulence. So here we are talking about very fast phenomenon. So you need to actually have data thousands times per second. So you need to process them also thousands times per second, and you need to apply the correction on the deformable mirror also thousands times per second. And when you do so, you hope that the star that was doing like this before actually goes back behind the mask, and now the light is actually blocked and you can see the companion. So this is a double project actually, EVWACO. On one side, the coronagraph itself, the mask, which is a part of a PhD student here, and the AO system that I am in charge of developing here at NARIT. Astronomy is a very interesting subject. There are many questions to answer. So if you hesitate to actually work in the field, I would just encourage you to do, because this is a very fascinating subject. And NARIT in Thailand is actually an amazing research institute doing great in terms of science and public outreach. So I am very impressed by what I found here, actually.